Hello and welcome to this lecture. In this lecture we will develop a high-level understanding on transfer learning and pre-trained models. Imagine you want to train an image classifier and you don't have many data for training. In this case you might use some data augmentation to change the images and make it appear more data than it actually is. We will have a lecture on this as well in the future. Another way is to use already trained models. We make use of a pre-trained model in this case. This technique is also called transfer learning. And what are the benefits? You make use of existing weights and existing features. Only the relationship of features to new classes needs to be learned. You get a model with better performance and you save time. You can see this in the graph at the right side. The performance of the model is shown as a function of training time. Without transfer learning, you start at 0 and your performance increases slowly with training time. With transfer learning, many features are already known, so your performance is quite decent even at the start, and it will further increase with more training. You also rely on a tested architecture and you know that the architecture is performing well. How is it used? You can see a model that was already trained. It has an input layer, some convolutional base, which means lots of convolutional and pooling layers stacked together, and at the top a dense layer with some class labels. Now you want to apply transfer learning. You take the convolutional base of the pre-trained model and keep it. Together with some new input data and new dense layers at the top and new class labels, you can train the new model. Here is an example. We have a pre-trained model for different cat types. Many images of different cat types are fed to the model and it learned to understand the specifics of different classes. In the convolutional base, the features are learned, from very low-level features like edges and curves to more complex features like legs, ears and noses. And now you want to create the dog type classifier. You could run everything again and follow the same approach as with the cat type classifier, but imagine the training took several days. Now everything has to be learned again from scratch. Actually, there is a much better way, transfer learning. This works because dogs and cats are quite similar. Both have 4 legs, fluffy fur, 2 ears and eyes. All these features don't need to be learned again. We can take the convolutional base from the cat type classifier and reuse it for the dog type classifier. We replace the input layer and some layers at the top and can, with this technique, speed up the learning process extremely. There is publicly available image data and neural networks that were trained on them. ImageNet is performing challenges every year since 2010 for large-scale recognition of objects in images. There are 1000 categories and more than 1 million images used for the modeling. Some sample images can be seen at the right side. And for this data, many different models were created. One of them is VGG19. It is a deep convolutional network for large-scale image recognition and was specifically developed for the ImageNet challenge. At the right side you can see the network architecture. The images have a size of 224 times 224 and 3 channels. These are then passed to several convolutional and pooling layers, and finally there are some dense layers, and at the very top there is a layer with 1000 nodes and a softmax activation for the prediction of these 1000 classes. If you want to train some specific classifier on your classes, you might take the convolutional base and just replace the dense layer at the top and thus adapt the pre-trained model to your needs. In this lecture you have got an understanding on what transfer learning is, why it is useful and how you might apply it. That's it for this lecture. Thank you very much for watching and see you in the next lecture.